All right, guys, today we are going to take a look at some properties of natural log and natural log derivatives. Okay, before we get started with that, there's a couple of properties that I want to make sure to remind you of. Okay, first of all, we should remember that natural log of 1 is equal to 0. Okay, very important when we are simplifying things down. Second, the natural log of e is 1. Again, very important when we are simplifying down. The next one has to do with multiplication. When we have the natural log of a times b, we can break that apart into an addition. We can call that natural log of a plus natural log of b. When we have division, we can do the opposite. We can turn it into a subtraction. So if we have natural log of a divided by b, we can turn that into natural log of a minus natural log of b. And finally, there's an exponent property that is also extremely useful with what we do, which says natural log of a to the nth power, we could rewrite, as n times the natural log of a. Okay, so we can put that power out front. That becomes extremely useful when we are either simplifying things down. Before we take a derivative, sometimes we want to simplify this function down and turn it into an addition or a subtraction, depending on what we have, so that we can make the derivative a lot easier to take. Okay, so I just want to practice really quick. I'm going to do two problems where we are just going to expand them out, use our properties. Let's say that we have natural log of x divided by the square root of x squared plus 4. Okay, and we want to expand this out. Okay, first of all, we have natural log of x, and now this is divided, so we can subtract. We have x squared plus 4 that's inside the square root. Remember, a square root is a fractional power. That would be to the power of 1/2. So we're going to pull the exponent out front. 1/2 natural log of x squared plus 4. Okay, so this would be expanding this out, and that would make it a lot easier to use this function to take a derivative if we needed to, which we'll get into in a minute. But I just wanted to make sure we feel pretty confident with these, making sure we're good with simplifying these down. Let's say we have natural log of 2x times the square root of 3x plus 2. Let's talk about simplifying that down. Natural log of 2 plus the natural log of x. Notice 2 times x, so we can break those apart. Plus, we have the square root of 3x plus 2. So square root, remember, is a fractional power. So we're going to have 1/2 natural log 3x plus 2. Okay, and that would be expanding that out. That would make it very easy to take a derivative if we needed to. So let's get started looking at derivatives. Okay. Okay, derivatives of natural log functions. If we let u be a differentiable function of x, then the derivative of the natural log of x is 1 over x, provided that x is greater than 0. The derivative, this is where the u comes into play, of the natural log of u is equal to u prime over u. Again, provided that u is greater than 0. We can't take the natural log of 0 or a negative number. One other that I want to make sure that I point out because it has to do with absolute value, the derivative of the natural log of absolute value of u is still u prime over u, provided that u is not equal to 0. Okay? Now, these are extremely easy derivatives to take, or they should be. Okay? Once you've identified what your function is inside of the natural log, you take the derivative of that and you divide by that original function. Okay? U prime over u, either way, even if you have an absolute value. Now, the one thing that I want to make sure that we point out is that it is extremely hard to do this if you don't know how to simplify down natural log functions, because a lot of times you may have things multiplied or you may have things divided, and you have to make sure that you can separate them before you try to take a derivative. I cannot tell you the number of complicated, ridiculous derivatives I've seen people try to take because they won't simplify down to begin with. Let's take a look at an example of what I'm talking about. Let's say that we have f of x equals, let's start with a basic one. We won't have any addition or subtraction, but we'll just have to simplify using our exponent rule. Let's say we have the natural log of the square root of x plus 1. Okay? Before we try to take that derivative of u, so before we try to get u prime, u in this case would be square root of x plus 1. But we know an easier way to write this one out, so we don't have to deal with the square root anymore. We could rewrite this as 1/2 times the natural log of x plus 1. Now our function is a lot easier that we're dealing with on the inside of the natural log. If we try to take that derivative, 1/2 is just a constant. Now let's take a look. We want u prime over u, so I'm going to go ahead and write the u on the bottom, and then derivative of x plus 1 is just 1. So we could rewrite this as 1 over 2 times x plus 1. There's our derivative. That is so much easier than trying to take the derivative of square root of x plus 1 all over the square root of x plus 1. You're going to end up with the same thing, but it's much faster if you go ahead and just simplify before you take that derivative. Okay, let's take a look at another one where it's going to be even more complicated if you tried to do it without simplifying beforehand. Let's say that we have natural log of x times, I'm going to make it super complicated, so we have to simplify it. X times x squared plus 1 squared all over the square root of 2x cubed minus 1. Okay, now this is what I'm talking about. Can you imagine trying to take this derivative? We would have a quotient rule, and we would have a product rule, and we have chain rules. That would be insane to try to take that derivative. That's where, again, I've seen some crazy stuff people have tried to do because they won't simplify to begin with. Whereas let's try simplifying this down before we take the derivative. If we simplify and expand this out, we've got natural log of x, right? Plus, because it's multiplied, exponent of 2 comes out front, 2 natural log of x squared plus 1. Now we want to subtract because this piece is on the bottom, so minus, it's a square root, so that's a power of 1/2 that we're going to bring out front, natural log of 2x cubed minus 1. Now, even though that looks complicated because you got 3 pieces, it actually ends up being way easier to take that derivative. Let's talk about working through finding the derivative. Derivative of natural log of x, 1 over x. We wrote that rule down. Plus 2 times, because 2 is a constant, derivative of natural log of x squared plus 1. Remember, it's u prime over u. So I'm just going to put the u on the bottom, x squared plus 1. U prime, derivative of x squared plus 1 would be 2x. Minus 1/2 times, 1/2 is just our constant, u prime over u. U is 2x cubed minus 1. So I put the u on the bottom. U prime goes on top. Derivative of 2x cubed minus 1 is 6x squared. Now, all I want to do is simplify. Okay, let's deal with these constants that we're multiplying by. 2 times 2x gives us 4x over x squared plus 1 minus 1/2 times 6x squared gives us 3x squared over 2x cubed minus 1. So that is our derivative. We're not going to get any common denominators. We don't have to deal with that ever. Okay, we can leave it like this. Then it's easy to plug something in if we need to. Okay. We can use the derivative in the same way that we've used it for everything else. We can find slopes for tangent lines. We can find where functions are increasing or decreasing. Any of those things we can still use the derivative for. Those properties are still the same. We're just now applying them to natural log functions. Okay, let's also try one where we might have some trig. Okay, let's say we have the function natural log of the square root of 1 plus sine of x. And let's say we want to find derivative. Before we do that, remember, we can simplify this down at least a little bit, make it a little bit easier on us. This is all in the square root, so that's the 1/2 power. I'm going to bring the 1/2 out front. So this is 1/2 natural log of 1 plus sine of x. Now, if we try to take the derivative, 1/2 is a constant. Take derivative of natural log of 1 plus sine of x. Remember, that's u prime over u. Our u is 1 plus sine of x. Derivative of 1 plus sine of x goes on top, and that would be cosine of x. So if we simplify this down, we have cosine of x over 2 times 1 plus sine of x. That's our derivative. We can now use it in any way we needed to find slopes of tangent lines or anything else that we might need. Okay, we could then go find a second derivative if we needed to using quotient rule. Okay. All right, let's try one other type. I want to show you we can still use our other rules, okay, even when we have natural logs in the functions. So let's say we have x cubed times natural log of x. Okay, if we have this function and we want to find the derivative, notice that we have a product. So we're going to have to use product rule. Let's go through that product rule. First one, x cubed times the derivative of the second one. Derivative of natural log of x is 1 over x. Plus the second one, natural log of x, times derivative of the first, 3x squared. So let's just clean this up a little bit. X cubed times 1 over x reduces to x squared. And then plus, I'm going to move the 3x squared out front. 3x squared, natural log of x. The most we could do is take out an x squared because both terms have that. That's not really super necessary. That would become 1 plus 3 natural log of x. That might be useful if you're trying to do something with the derivative where you're setting it equal to 0. That's the only way that might really be useful, because then you would be able to get your solutions. But otherwise, if it's just a free response where you're only finding the derivative, you can leave it in that first form. Okay, it depends on what you need for the problem in order to decide what you need to do with that derivative once you take it. Okay, let's try maybe one more. Let's do another one where we're using one of our other rules. Okay, what if we have, let's see, let's come up with something else. What if we have something like this? Okay, so let's say we have natural log of x all squared. Now, here's the thing that I see a lot of mistakes in. This is not x squared, right? This does not equal the natural log of x squared, right? This is the whole natural log of x function being squared. So a lot of times the mistake that I will see is people will try to rewrite this, and I'm going to put not equal to so we make sure we don't. They will try to rewrite this as 2 natural log of x, but that is not equivalent. Okay, that is not equivalent because the whole function natural log of x is being squared, not just the x. Okay, these are equivalent, right? We can take the power out front when we have natural log of x squared, but we have natural log of x all squared. Okay, so I'm actually going to erase so that we make sure that we don't ever think that we are going to use this. Okay, make sure we don't rewrite it like that. That is a mistake that I see that is very common. Okay, so make sure you know where your exponent is and what it applies to. Okay, now let's go back and let's take the derivative of this function. We're going to have to use chain rule in order to do it because we have natural log of x all raised to the second power. All right, let's try using chain rule. Power out front times the function now to the 1 less power, so it's now to the 1. And then we have to multiply by the derivative of what's inside. What's the derivative of natural log of x? That's 1 over x. Okay, so let's just simplify down a little bit. We have 2 natural log of x, and then the x can go on the bottom because we multiplied by 1 over x. So that would be our final equation for the derivative. Okay. Again, please be careful about your notation. Be careful about where your powers are because that's a mistake that I see a lot, especially when we start to combine some things. Notice that we were putting, natural log derivatives and chain rule together. So please be careful about that. That's one of the biggest mistakes that I see with these.